All right, let's dive into one of the biggest ideas in all of software, object-oriented programming, or OOP for short. You know, if you really want to master a language like Java, you've absolutely got to get your head around this concept. So, let's get right to it. So let me ask you a question. What in the world does a detailed blueprint for a car have in common with the code that runs on your phone? I mean, they seem like totally different universes, right? Well, it turns out this very idea is the key that unlocks everything.
It all starts with a plan. You know, that detailed design you make before you even think about building something real. It's all about the power of having a solid blueprint.
And this is where it connects directly to programming. See, a car blueprint, it defines everything, right? The engine size, how many doors it has, the color options, the whole deal. Well, in the world of Java, that blueprint is called a class. A class is literally the master plan. It's the template that describes what a thing in our program is going to be and what it can do.
But a blueprint is just a plan. It's just ink on paper. The real magic, the fun part, is when you take that plan and you build something real with it, when you go from the drawing board into the real world.
And here's the aha moment. If the blueprint is our class, then that shiny car rolling off the assembly line, that is our object. It's a real, living, breathing instance created from that master plan. You could have a red sports car, a blue family sedan. They're all completely different objects, but guess what? They were all built from the very same car class blueprint. And that's the crucial point, this one-to-many relationship. You do all the hard design work just once when you create the class. And after that, you can stamp out as many unique objects, as many cars, as you could possibly need. This is the heart of reusability in programming. And let me tell you, it's incredibly powerful. Okay, so we've got our blueprint and we've got our real car. But how does a car actually work without being crazy complicated for the driver? That brings us to our next huge idea, protecting all those inner workings. Now, the official term for this is encapsulation, and the name kind of gives it away. The whole idea is to bundle all the complex, messy internal parts, the data and all the actions, into one single self-contained unit, just like a capsule that keeps everything packed together nice and tight. Just think about how a real car works. It's the perfect example of encapsulation. You've got the engine, the transmission, miles of wiring. It's all bundled up and hidden away under the hood. As the driver, you don't need to be a mechanic. You don't need to understand internal combustion. You're just given a super simple interface, a steering wheel and a couple of pedals. All the complex, greasy mechanics are protected, making the car safe and incredibly easy to use.
So, theory is great and all, but how does this actually translate when you're typing away? Let's take these awesome ideas, classes, objects, and encapsulation, and see what they really look like in a bit of code.
And there you have it. This is getting pretty close to what you'd see in real Java. We define our blueprint with public class car, and notice what the outside world gets to see? Just the simple, easy-to-use actions, start and stop. All the complicated logic, you know, what it really takes to get the engine firing on all cylinders, that's all hidden away inside those curly braces. It's totally encapsulated, so anyone can use our car object without having to be a programmer mechanic. And that, right there, is the big promise of this whole approach. You're taking incredibly complex systems and making them simple on the outside, powerful on the inside, and of course, infinitely reusable. That is the goal.
Okay, so let's zoom out for a second. Why do programmers all over the globe build software this way? What's the real big picture payoff for thinking in terms of blueprints and objects?
Well, it really comes down to these three massive wins. First, it makes your code modular. Each class is its own little self-contained unit, kind of like a Lego brick, which makes everything way easier to manage. Second, and we've seen this already, it's reusable. You write that car class once, and you can create 1,000, 1,000,000 cars from it. And finally, it's scalable. You can build these enormous, complex applications by just snapping together these smaller, well-defined and encapsulated objects, just like building a real car from all its individual parts.
So, we've seen how a simple idea, a blueprint for a car, gives us this incredible model for writing cleaner, more organized, and way more powerful code. And that really just leaves us with one question. Now that you have the blueprint, what are you going to build?